So let's just go around the room. Let's see what we've got here. And I'm going to go down here. And let's see. Let's start with Darius. Number 1, true, false.
You want to read out loud each one?
Sure.
Okay.
Read out loud and tell us what you think. I've got it really big on the screen if you want to use that.
One purpose of dimensions and tolerances is to define the manufacturing setup. I would say that's true.
That is true. That's one reason. Number 2, let's go to Halen.
So number 2 says relationships between part surfaces should be defined based on their function in the product. Is it true?
That's true. Very good. Because if I need these two to be, a certain distance for something, they have to be related to each other.
Yeah, could that also be talking about like data surfaces?
Yeah, it could be. James, number 3.
The nominal size of a dimension is always the mean of the tolerance values. True.
That's not always true. It's not always. Look for always in true false. If you've ever made up, I hate true false, having to make that up.
Yeah.
The nominal size is not always the mean of the tolerance values, because I might have this right here. So I might model it to the mean, but this is my nominal. Does that make sense?
Or what if you had one of the ones like you said with a limited dimension where it only has 1 and like a plus? So
Like
two.
this?
Yeah,
Yeah, that's a nominal.
yeah.
So I don't,
That's not between the top.
right. So sometimes I have to find the nominal because it just gives me a high and low. But usually the nominal is just a number that we're given. Okay? Good. Number 4, Ian.
Under ASME Y14.5, all dimensional limits are absolute, which I believe is true. You can't have any like rounding or anything in the decimals.
That's right. Absolutely. And Anna, you want to read number 5?
A single feature control frame is required to have 5 or more compartments.
Okay, it didn't even talk about that, right?
That would gotta be false though, right?
It is false. But let's talk about a feature control frame. You guys remember flatness in 1433? Something's flat to itself. So if we had flatness, we would have this,
Yeah.
and then we didn't even have a datum, and then we would just say, so that's 2 compartments,
Yeah.
right?
A lot of
So I don't even know, it didn't even talk about that in the chapter, but that is false. It is not required to have 5 or more. It can have up to 5. Number 6, we're back to you, Darius.
Basic dimensions are usually specified by enclosing the dimension in a rectangle. That's true.
That is true. Number 7, Halen.
So this one says the sequence of listing notes indicates the importance of notes. 1 is more important than 4.
Is that false?
That's false. And, that was in there and we didn't go over that. But, at some companies we would actually put, the part marking last, because that would be the last thing that you would get to. But there is nothing that says that I couldn't have had that first. Right?
Yeah, it kind of makes sense that you would want to have like the most important thing first, so it'll get lost. But you could have stuff like
Yeah.
the.
So in essence, the standard does not tell us that we have to do that, because that is a matter. Think about that as an opinion. Someone's opinion could be different than someone else's.
As long as everything makes it into notes, it's fine.
That's right. So number 7 is false. Number 8, James.
Using CAD models rather than an engineering drawing will eliminate most sources of variation. False.
False. It will not eliminate sources of variation, or most of them even. Number 9, Ian.
Dimensions are used to define size, location, or orientation, and filtering of a part, feature, or feature size. I think filtering is supposed to be form, so false.
Good. I don't even know what filtering would mean.
Yeah,
So that is false. Form is correct. Very good. Number 10, Anna.
The two common linear units of measure are the decimal inch and the meter. That's false because it's given here.
Very good.
Yeah.
Yeah, you gotta be, man, tricky true false questions, right? Very good. That is false. All right, multiple choice. Number 1, Darius.
Which areas of a company are most directly impacted by dimensions and tolerances? I would say D, all of the above.
Yes, all of them. Remembering that when we design something, we have to think it all the way through. So we have to take everyone into consideration. And a lot of times I'm going to go ask those people. I go to inspection, talk to them. I go to the shop and talk to those guys. And that really creates a good team, you know, because they'll appreciate that.
Because people from different parts could offer insight on something that you maybe hadn't thought of.
You know what else? They appreciate you that you give
Yeah, not just.
a hoot.
Something.
Let me- Yeah, you're not shoving it down their throat, right? And they do have something to teach me at all times. Number 2, James.
Which is correct, which is the correct means of using plus minus tolerances to permit 0.6 millimeters of variation.
Okay, be careful on this one. Because what he wants, if it's the same above and below, he wants you to put a plus minus 1 number. That's not a standard, but that's what he wants. So when it says plus minus the same thing, but it has both those numbers in the plus minus, he's thinking that that's incorrect, okay? So what is correct?
Wait, that's good.
So A is the incorrect one?
A is incorrect. What about C? Is that incorrect?
No, that's correct, right?
Well, we can't have a plus or a .0 after that. Remember, when it's unilateral, it will be nil.
B is also C. I was thinking of real C.
Oh.
They both say C.
So let's follow like this one. A, B, C.
Okay.
Okay. So yes, you are correct if you're thinking plus 4 minus 2.
Yeah, that's the one I thought would be right.
Yes, because this is the way we want to do unilateral. Has no plus or minus, no, it does not follow the same number of digits. That's only in limits. The first A he's saying is incorrect because he uses plus minus 0.3
Yeah.
instead of plus 0.3 minus 0.3. All right? So good job on that, you guys. So C is correct.
Wait, what?
The one below A.
Wait, that's gonna be B, right?
B, I'm sorry, B is correct. The one below A is correct. Plus 0.4 minus 0.2. All right, Ian, what do you think about 3?
In the specification, 20 plus 0.4 millimeters minus 0.2 millimeters, the value 20 is known as the nominal value.
Very good. Okay, number 4, Anna.
Dimensions and tolerance are used all the above.
Good, very good. So D, all the above. Number 4, number 5. Back to you, Darius.
Dimensions and tolerances may be related to a CAD model by
I think C is correct. What do you guys?
Yeah, I'd say D for A and B.
Yeah, you're right.
Okay. Okay, we gotta have, it should be B because it's gotta be associated with this spec. We got to tell people how to go into the model and find out what that is. And that's what that standard does.
So only B.
B. As in boy. Okay, good. And that is a little bit confusing with A and B, indicating them on a separate engineering drawing associated with the model It may be D. I don't know, I'm gonna have to look at that one. I don't have my cheat sheet on me. But I think it's B, because if you just had this on a separate engineering drawing without the standard on there, then I don't think it would be right. So let me look at that one. Number 5.
It just says a document associated with it, that could be a PDF.
Good enough.
There you go. So I'm gonna verify that for you guys. Number 6, Halen.
Engineering drawing notes should be, yeah, present tense.
Yeah, C in the present tense. Certainly not in the past,
No, that
in an alphabetical order.
doesn't matter or anything.
James, what about number 7?
Okay, the proper use of zeros for plus minus tolerances expressed in millimeters requires. A.
A is good. B is good.
And C is.
Yeah. So, yeah, just remember this. Just remember this. We got this. We don't have trailing zeros over here. We always have leading zeros here. But the one that really kicked it off for me, that I didn't know before this book, was that if I had 2 digits to the right in a dimension and 1 digit to the right, I had to put another 0 to make these a uniform number of decimal places. In limits only. I had never seen that before. That was brand new to me. Because I don't do a lot of limits tolerance either. I do one way, but I have not done that either. Okay, so let's go on to, let's see what else. Ooh, lucky. What we got? Yes.
I was just wondering about time question. Class usually ends at 7:25.
Oh, I'm so sorry. So you guys can go ahead and go, and I'm going to stay here and go through these questions. Yeah, thank you for letting me know. I could go all night. This is fun. What are the numbers for the general notes?
1, 2, 3, 4, 5.
1 through 5. There you go. List all the local notes. So we've got electro etch right there. That's a local note. 2 surfaces.
2 surfaces.
Some people might say through.
Yeah, I was gonna say, would the through be in that?
I don't even put that on my drawings, you guys. I don't know. I just let it. If I don't have a depth, it's assumed to be through.
Yeah.
Yeah. So you can put through if you want. I will not count off for that, but those are the local notes.
Electro etch 2 surfaces.
Yep. And you can put D or electro etch. It's up to you guys because this is denoted by D. Now watch out because sometimes it's going to want you to say, and in the questions it's going to tell you by the circled letters or numbers, okay? So list the numbers of the flag notes. You guys see any flag notes?
No.
Then you say there are none. If there are no symbols around any general notes, you do not have flag notes. Okay, there are no flag notes on there. There could be for this one, if they had this as a note, right, for the part marking. List all the limit tolerances. So this is where we're going to use the circled numbers, okay?
B, F, C, and E.
B is equal bilateral. Now limits is going to show the high and low.
I'm thinking too hard.
Don't think too hard about it.
Yeah, it was G and
A,
A.
G, and E, no.
A, G,
E's not one,
E is not one. Just A and G,
Yeah.
okay? A and G. It says list the bilateral plus minus tolerances. Bilateral,
1, 2, 5. B,
No, that's unilateral. So F and E,
F and E,
that's good, good, good.
or is it just F and E?
I think so, because the rest are limits or equal bilateral, or
Yeah.
we'll talk about that. And list all the unilateral
It's just C.
C.
C. And that's it. And then let's see what else. List all the limits and plus minus tolerances that are incorrectly specified, and remember that he wants you to put a plus minus. If it's the same plus and minus, he wants you to list that, not separately. So he's saying that this is incorrect. E is incorrect because it should say plus or minus 1, but also it's incorrect because it has trailing zeros. That's a whole number. We don't have dot and trailing zeros, right?
Yeah.
What about F?
F is wrong.
Yeah, you can't have a plus zero.
That's right. We don't have a plus. We don't have a dot and zero. So F is incorrect. It should say just a 0 above and something minus. I think that's kind of crazy. But anyway, I see which way it goes. What about G? That is a limits tolerance.
Oh, this is-
Remember this?
Minus
Yeah, it's got to have the same number of digits.
Yeah, there's no, should have a point zero.
That's right. Same number of digits. Very good. And so C looks good. So what do we get? G, F, and E?
Yep.
All right. E, F, G. Okay. And show the correct specification. Well, we already talked about that. This should be plus or minus 1. Now, it's not plus 1 minus 1. He wants to see plus minus 1, right?
It's the same number.
Yeah. And then this one would just have a 0 above. And then this one would be 32.0, so that these have the same number of digits.
Large number of.
Very good. So you're going to write that out. So remember that one.
So how would we put that in Blackboard in the quiz?
You're just going to type in the correct thing. Oh, very good question. When it's a plus minus, you're going to do it laterally. So it would look like,
Yeah, I was curious about Okay.
make sense?
Yeah.
With the dash?
Yeah, just like a,
Because you got to do it laterally, it would be funky if
yeah, just
not.
like a fraction.
Yes. Kind of like a fraction with a dash in it. So it'd be plus something dash, like a slash, sorry, like a division slash, minus whatever that would be. But you put the plus first. And so, let's see. Number 9, what is a linear unit of measure?
Millimeters?
Says right there, it should always say in your template, very good. Are the angular units correctly specified? Why or why not? Where are they? There are none.
Yeah, there's none.
So, no, they're not correctly specified because there are none, okay? No angular units.
Not applicable, or just.
You could, yep. Let me see if I can get back to my same spot. I really buggered that. Okay, let me get down here again. Sorry, make you guys dizzy.
Did we skip the angular unit of measure for that question?
Yeah, we did. So what is the linear unit of measure? No, the linear unit of measure. We did that. Angular unit.
Is it degrees?
It is degrees. So we'll look in the tolerance block for that. And it says angles right there.
Yeah.
We don't use degrees, minutes, and seconds because that's extremely precise. Or the angular, we already talked about that. How are the tolerances related to the CAD model? You guys see anything that says that?
2.
Yeah, there you go. It says round all queried values to 1 decimal place. So if they go into the model and measure something, they round everything to 1 decimal place. 3D CAD model is modeled to the mean dimension. For features not dimension, interrogate. Woo, that looks scary to me. All right, you guys got it? Thank you so much for today. We are going to talk about your next exercise on Wednesday, and that will be exercise 2. So if I pull this over here to show it to you, we go down to exercise 2, right here, comparing the part files to ensure correct modeling of the crankcase. Now, it may not be the correct modeling. I just want you to make one part match. I want you to make your part match the part that you import. And we're going to talk about how to do that, what it looks like. And you guys may want to try to start modeling things that you don't have input for.
And so that's.
Download something and start
You're saying
modeling.
We will submit our part, it could be wrong.
You submit your part anyway tonight.
Yeah, and how, when we come to this exercise, that's where we're gonna make it correct, okay? That's
You're
what-
not even going to make it correct. You're just going to make it like that one.
Yeah.
That one may not be correct.
Match
Yeah.
match it to the.
That's it. That's it.